standard prototyping board, which means on one side no copper, the other side has copper. Whenever you're soldering something like this, you're usually doing through hole, or what's called through hole, which means that the part goes through one side. So even though I'm populating stuff on this side, I'm not soldering this side, I'm soldering the back side. So the solder is connecting between the pin itself and the copper, okay? The second part of this is that I want to have a nice even distribution all the way through, which means getting the part flat. So you can see here, this one is relatively flat, this one's relatively flat, but this one's at an angle. So the pins all kind of go off on the right hand side. Part of that problem is when you put it in, this actually rocks back and forth. So when you turn it over to solder it, you have to be aware that this angle can change.
You can put it on the breadboard, so I'm using breadboard.
So you can put it in a breadboard. That's a good example of setting it up so this is done. But when you push down through here, it actually changes the distance between all these pins. So it can make it harder to get an even fit. You see that it's actually bowed now?
Yeah,
I'm just gonna
you can get another board. I have
see like that? It's actually bowed on the curve. So it's better not to use a breadboard to do a row of pins like this. It's better to get it flat on its own.
Yes, I have a more straight breadboard. This one is curved, I know that.
Well, because when I push down, it actually changes it. So now, if you look, this side's slightly higher than that side. So can you see?
Yeah, it's uneven.
Yeah, it's uneven because I pushed down on this to get it into this. This takes a lot of force.
Okay.
So it slides up and down. So you can do it like that, but you run the risk of making this almost uneven across and hard to use. So normally it's actually better to put it in on one side. Make sure that it's square like that. If you're gonna turn it over, you can, but this side needs to be supported too. So this is okay. Having something underneath on this side is better, just because then I have a square connection between these two, and then verify that it's done like that, that this is actually square and sitting square against the thing. Then what I want to do is make sure that my soldering iron's on. This is at 298, 299. I'm just gonna take it up to 310. Oh, other direction apparently. 310 or so. The range is 310 to 340. Anything over 340, you're probably going to damage the tip. So once this gets up to temperature, 310, I'm gonna take some of the solder in this case, stretch it out, and then just see if it'll melt against the tip. So that's good. I'm gonna scrape it off, or I can wipe it off if it looks like there's a lot of oxidization on it, but what I really want now is a shiny tip. So I'm just gonna melt some onto the tip like that, let it roll around, and then dab it in here to get the tip shiny. So I don't know if you can see that, but the tip's a lot shinier. Okay. For all of these things, make sure you have proper ventilation, because if you don't have good ventilation, you're gonna end up breathing the fumes. They are super toxic. So in this case, this is a fan with a carbon filter in front of it, and it pulls all of the fumes through. So this is called a fume extractor. You can actually get these super cheap on Alibaba or AliExpress. But the idea is that you don't want it to end up rising straight up or breathing it in. So if you can help it. It's not gonna kill you, but it's not pleasant. Then once you have that going, normally what you're going to do is tack it down. So I'm gonna pick one pin, whichever one's the most stable, probably this one. Make sure I'm still square. Touch the edge of the ring, the copper layer, and the metal layer at the same time. So what that does is it makes sure that you have an even connection between both of them. They both have to be heated equally for it to work. And I can leave it on there for a little bit longer, but what's gonna happen is if I leave it on the pin too long, you're actually gonna melt the plastic or anything attached on the other side. So you can totally burn a component out by leaving it on there too long. So in this case, I'm gonna square this up a little bit. Okay. Put it down, hold it, and then just put enough solder on. Since I don't have my goggles on, I can't actually see. Just to hold it in place. It doesn't have to be perfect, but now what it's done is this will sit here. And it gives you a chance to also to fix it if it's wrong. I don't think the temperature's high enough. But now it should be tacked on, which means that this side is flat against, and they all line up, and it's not going to wiggle. So now if I go through and I try and solder, then all of the rest of the parts should stay square against it as well. And now you don't have to really worry about bracing it as much. Each one is basically going to be the same motion, which is sticking it across. It's also better if you have goggles so you can see physically like how your contact is. In this case, I want to make sure that I put a little pressure against both pins, put it in, and then I'm going to put it against the pin first. Hopefully the pin will melt it, but if not, then I can go against the iron and the pin at the same time. The 3 seconds is like just a nice easy there. While I'm holding it, I take out the solder. So it's still hot. The solder goes on, I pull away. Then I take it off and just let it sit. Don't move it, because while it's cooling, it's forming a crystalline lattice. If I move this while it's in that position, I'm actually going to form a cold joint. And so then I just do the same thing, right? Until I get all of these. Then once I'm done with that, I want to go through and make sure that I periodically go through and get rid of any oxides that I'm getting. Scrape it off, put it into the holder, and turn it off. Okay. But now, just for